Hi, I'm Keegan, and this is my infographic. I want to first talk about my forms of visual potential. Starting with how I exploited the visual potential of numbers. In my first display, my goal was to show a sense of how efficiently energy is being used in the world. In particular, I wanted to juxtapose the energy demands of the top energy consuming countries with their energy consumption per person. So, when choosing what type of chart would work best, I knew I wanted to compare amounts across different categories, which brought me to decide between a bar chart, bubble chart, line chart, heat map, or isotype chart. Initially, I thought a heat map would be super cool, but I realized that those worked better with large data sets, and mine was relatively small. A line chart wouldn't work well with my data either, seeing as I only had two data points per category. I thought an isotype chart might be interesting, but I thought my data was a bit spread out for it. So this really left me with either a bubble chart or bar chart, which worked perfectly since I needed two versions. I like the symbolism used in isotype charts, though, as it tends to convey context well at a glance. I incorporated this sense of symbolism into my bubble chart by using light bulbs to symbolize energy use. However, I use size, color, and position to encode data in them instead of just using the isotype style of amount encoding. This didn't really work as well as I had hoped, and it ended up being kind of confusing to viewers, so I switched to something more familiar and stuck with the bar graph. I really liked the example bar chart that was shown. Each bar had a darker inner bar that showed additional data, which I thought would be perfect to try out since it fit well with my data set. It also had a list of categories with bars coming out from both sides instead of just on one, something else I could try with my data set. Going through the critiques, I found that having my two data points for each country using two different types of units also created some confusion when I tried nesting the bar graphs. Because of this, I thought I would switch from a nested bar graph model to having the two bar graphs in different directions. It seemed to convey better that while the two data points were related, they were also different in some way. Between iterations, I did mess around with the wording and position of text of it too, and while those did help make the context more clear, I found that the type and layout of the chart itself made the biggest impact on the visual potential of the numbers themselves. It really made a big difference in both how the numbers relate to the context and how the numbers vary amongst each other. For my second numbers display, I wanted to experiment with showing something a bit different with the data, so I decided to focus on the proportions of individual values compared to their sum. Looking at the example chart types, I thought the donut chart was a really cool and simple way to show the relatively detailed information, but I also remembered from my last display to be careful using something that was different from what people expect, so I also tried conveying the data using a pie chart, something a bit more standard. I found that people definitely thought the donut was cool as well, and thought it was nice because it was less in your face due to having less fill. I also recognized that I had a lot of pieces in my donut, and many of them were small slivers. So, seeking to innovate and noticing how much real estate color labels take up without providing too much information, I thought, why not just encode the same information present in the donut into the size of the color labels? While the donut did a good job of highlighting the difference between the portion of renewable and non-renewable energy types themselves, I also wanted the users to, upon closer inspection, be able to get a more detailed view of the differences between the actual sources within the types. While this did end up introducing a little bit of ambiguity, it was generally quite successful and had the added benefit of making the lesser visible slivers a bit more apparent. My next display exploited the visual potential of location. So the goal of this one was to convey the proportion of each state's energy that comes from renewable sources. So this was to provide a sense of how clean the energy from any given state is. I started out testing this display with two different types of encoding, size and color. I really liked the size encoded one at first since it freed up the colors to be used for a monochromatic consistency that felt very clean and nice compared to the color encoded version, which felt a bit too chaotic for me. I quickly realized that using size encoding via bubbles on each state just didn't convey the data as well since people had a hard time distinguishing the different bubble sizes and couldn't quite see the bubbles on the smaller states. Plus, it wasn't clear if the bubbles represented data for the states or cities within the states. Color encoding was the obvious choice here since it made it much more clear precisely what was going on and capitalized the available real estate better. So in an effort to adhere to the simplicity of my base model, I made the display use a small set of color stops instead of using a full spectrum color gradient, which was the default on Tableau. This actually had a wonderful effect of reducing the perceived chaos by increasing the color unity within the display itself. I thought it also increased the effectiveness of the display as a whole, since the entire point of the display was to demonstrate the answer to a where question. This really highlighted the few areas that had high renewable energy usage as well as the areas that didn't by aggregating them together into only a few small groups. Before, while you could get a better feel of the slight differences between the neighboring states, this more aggressive grouping gave a slightly more holistic focus, allowing the user to mentally point to a section and say, there, that's where renewable energy is being used, and right there is where it's not. So my next display was my appearance display. So really the whole focus of this infographic is supposed to be on how the world consumes energy and how we can reduce wasteful energy consumption. So within that context, my solution to reducing this energy consumption is something called passive design, where the energy present in the surrounding environment is used in lieu of explicitly importing energy from other man-made sources. Since the point of an appearance display is to provide some insight into what something generally looks or feels like, I thought this would be a good opportunity to show the user a glimpse of what passive design is, since they will likely aren't familiar with the concept. This display was an attempt to demonstrate a simple passive design technique that exemplifies the principles of passive design well. This technique involves the use of a roof overhang to block the unwanted heat of the summer sun while still allowing the heat from the winter sun to come into the house and reduce the need for heating using external sources. I really wanted to use this as an opportunity to make a display that was simple, easy to understand, and effective at conveying a concept. While the other displays had a fair amount of data they were trying to convey and might rely more on text to fill some gaps, the lighter weight nature of this display meant the amount of text used could be minimized as long as they made a really intuitive and symbolic graphic. This is nice. It allows the user to understand exactly what is going on at just a simple glance. So my next display is my relationship display. So when I first learned about relationships as a form of visual potential, I thought it was relatively straightforward, but I quickly ran into some trouble thinking of information relevant to my topic that fit the criteria. It's a surprisingly abstract concept, but after a good amount of thought, I finally came to the simple realization that the flow and transfer of energy in a housing environment was essentially what passive design was, more or less, centered around. This was a prime example of elements of the housing environment relating to and affecting other elements within the same environment. After researching some more passive design techniques, I came across one that I thought was complex enough to have multiple parts relating to each other while not being so complex that it would overwhelm or otherwise deter the viewer. The passive design technique of choice was called the Trombe wall, where heat from the sun passes through a window and is trapped in a wall that absorbs the heat. This affects the interior in two ways. First, the wall itself stores a large amount of thermal energy, which it then releases in the form of slow, even heating for many hours after the sun sets. This represents a source-destination relationship as heat travels from the sun into the thermal barrier and then into the living quarters. The second relationship being shown is the airflow itself. The air between the window and the wall, heated by the sun, rises and flows out through an opening near the top of the wall, flooding the adjacent living quarters with warm air and pulling in cold air from an opening near the bottom of the wall. This also represents a source-destination relationship, as cool air flows into the warm enclosure, heats up, and then flows into the adjacent room. My last display I'm going to go over is my time display. So time was an interesting form of visual potential, as I really wanted to focus on present issues and solutions moving forward, as opposed to the traditional past-centric timeline. When sifting through past design techniques, I stumbled across a bit of how the shape and orientation of a building can actually affect how much heat it absorbs and reflects throughout the year. I thought this could be an excellent example of showing patterns over time. The basic concept behind building orientation is that the intensity of the sun varies with the angle at which the sun strikes the surface. The more perpendicular the sun's rays are to the surface, the more energy it receives. Now, initially, I thought it would be awesome to make something like the example given where halo displays showed the brightness patterns in fruit throughout the year. Since each of my halos would be centered around the amount of heat coming from each cardinal direction, I could simply make a giant compass rose with a halo enclosing each north, south, east, west option, plus an additional option in the middle for the horizontal. This way, it could be intuitive that this display was representing directions as well as some change over time. While I was super excited at first, I realized that the key thing I wanted viewers to take away from this was the actual relative differences in heating between each face throughout different times of the year, since that would demonstrate well how much of an impact building orientation can actually make. Since separate halos in different locations would make that relative comparison quite difficult, I went back to the drawing board and found that the example charts in the time series category would allow me to highlight both how much energy a given face receives over time, as well as the relative differences between the different faces over time. I knew my base model liked using thick border strokes with thin internal strokes, coupled with the occasional use of fills and transparency. Brainstorming how to incorporate that into this display, I noticed that fills were often used with fills and strokes were often used with other strokes, but they didn't interplay too often. I tried to emulate that by having one display exclusively use fills and the other exclusively use thick strokes for lines. I thought that using exclusive thick strokes for lines wasn't prominent enough, so I incorporated some translucent fills to make the graphics more attention-grabbing. Critics found that the bold with translucent fill version was actually a little bit clearer and also allowed one of the lines that dipped behind the others to be shown better, so I went with that version. Reflecting back on it, this was a deviation from my base model, since my base model never mixes transparency with stroke. When it uses transparency, it only uses a single fully filled object. Also, while the translucent fills do increase visual prominence, they also reduce the visibility of the line that dips behind the others, whereas using exclusively stroke here wouldn't have had that issue.